most residential wiring situations, the answer is yes regarding arc fault circuit breakers. Specifically, all 15 amp and 20 amp circuits that supply receptacles or lighting outlets generally must be arc fault protected. This requirement is in place to enhance electrical safety and reduce the risk of fires caused by arcing faults. However, smoke detectors are an exception to this rule. Smoke detectors are typically not required to be installed on an arc fault circuit. It is crucial to consult the latest edition of the National Electrical Code, or NEC, and local building codes for the most accurate and up-to-date requirements in your specific jurisdiction. Arc fault circuit interrupters, also known as FSIs, are designed to detect dangerous electrical arcs, which are unintentional electrical discharges between two or more conductors. These arcs can generate significant heat and are a leading cause of electrical fires. FSIs are designed to trip and interrupt the circuit when an arc is detected, thereby preventing a fire from starting. The NEC mandates the use of FSIs in many residential circuits to improve safety. Understanding the specific requirements for arc fault protection is essential for electrical contractors, electricians, and homeowners undertaking electrical work. Failure to comply with these requirements can result in code violations, safety hazards, and potential liability. Firstly, let's look at the types of circuits that generally require arc fault protection. These typically include all 15 amp and 20 amp branch circuits supplying outlets or devices installed in dwelling units, specifically in areas like bedrooms, living rooms, dining rooms, kitchens, family rooms, hallways, and recreation rooms. These circuits often serve a variety of loads, including lighting, receptacles for appliances and electronic devices, and other general-purpose electrical equipment. The specific requirements may vary depending on the addition of the NEC and local amendments, but the general intent is to provide arc fault protection in areas where occupants are most likely to be present and where electrical hazards could pose a significant risk. Secondly, the NEC provides exceptions and specific applications where arc fault protection may not be required. These exceptions are often related to dedicated circuits for specific appliances or equipment, or to circuits that are already protected by other means. For example, a dedicated circuit for a refrigerator or a freezer may not require arc fault protection as long as it meets other safety requirements. Similarly, circuits that are protected by ground fault circuit interrupters, or GFCIs, may also be exempt from arc fault protection in certain situations. It's crucial to carefully review the NEC and local codes to determine whether any exceptions apply to your specific wiring situation. Thirdly, smoke detectors are generally not required to be installed on arc fault protected circuits. The rationale behind this exception is that smoke detectors are critical life safety devices, and it's important to ensure that they remain operational even in the event of an arc fault on a different circuit. If a smoke detector were installed on an arc fault protected circuit, a nuisance trip of the FSI could disable the smoke detector and compromise its ability to provide early warning of a fire. To avoid this potential problem, smoke detectors are typically installed on dedicated circuits that are not arc fault protected. These dedicated circuits are often connected directly to the main electrical panel and are designed to provide a reliable power source for the smoke detectors. Fourthly, it's important to understand the different types of FSIs and their respective applications. There are two main types of FSIs: branch/feeder FSIs and outlet branch circuit FSIs. Branch/feeder FSIs are installed in the electrical panel and provide arc fault protection for the entire branch circuit. Outlet branch circuit FSIs are installed at the first outlet in the branch circuit and provide arc fault protection for the downstream wiring and devices. Both types of FSIs are designed to detect and interrupt arcing faults, but they may differ in their sensitivity and response time. The NEC specifies which type of FSI is required for different applications, so it's important to select the correct type for your specific wiring situation. Fifthly, when installing FSIs, it's essential to follow the manufacturer's instructions and all applicable electrical codes. FSIs are sensitive electronic devices, and they must be installed correctly to ensure proper operation. Incorrect wiring or installation can damage the FSI or prevent it from functioning properly. Before installing an FSI, it's important to turn off the power to the circuit at the main electrical panel. Then carefully connect the F-side of the circuit wiring, following the wiring diagram provided by the manufacturer. After installation, test the F-side by pressing the test button on the device. The F-side should trip and interrupt the circuit, indicating that it is functioning properly. Sixthly, regular testing of F-sides is recommended to ensure that they are functioning properly. The NEC recommends that F-sides be tested at least once a month by pressing the test button on the device. If the F-side does not trip when the test button is pressed, it may be defective and should be replaced. Regular testing of F-sides can help to identify potential problems early on and prevent them from becoming safety hazards. Seventhly, troubleshooting arc fault circuit breaker trips can be complex. Nuisance tripping of F-sides can occur due to various factors, including faulty appliances, loose connections, or electromagnetic interference. When an F-side trips, it's important to investigate the cause of the trip before simply resetting the breaker. Start by unplugging any appliances or devices that were in use when the F-side tripped. Then, reset the F-side and see if it trips again. If the F-side continues to trip, it may indicate a problem with the wiring or the F-side itself. In such cases, it's best to consult with a qualified electrician to diagnose and repair the problem. Eighthly, the location influences arc fault requirements. While the NEC provides a baseline for electrical safety, local jurisdictions can amend or modify these requirements based on their specific needs and conditions. In Florida, for example, local building codes may include additional requirements for arc fault protection, such as requiring F-sides in more areas of the home or requiring specific types of F-sides. It's important to check with your local building department or a qualified electrician to determine the specific arc fault requirements in your area. Ninthly, staying updated with the latest NEC revisions is crucial. The NEC is updated every 3 years to reflect changes in technology, safety standards, and best practices. These revisions can include new requirements for arc fault protection, as well as changes to existing requirements. It's important for electrical contractors, electricians, and homeowners to stay informed about the latest NEC revisions to ensure that their electrical work complies with the most current safety standards. Subscribing to industry publications, attending continuing education courses, and consulting with qualified electricians are all good ways to stay updated with the latest NEC revisions. Tenthly, consider the future of arc fault protection technology. Arc fault protection technology is constantly evolving, with new and improved F-sides being developed to provide even greater safety and reliability. One area of focus is on reducing nuisance tripping, which can be a common problem with early generation F-sides. Newer F-sides are designed with advanced algorithms and filtering techniques to differentiate between harmless arcs and dangerous arcing faults. Another area of focus is on improving the diagnostic capabilities of F-sides, allowing them to provide more detailed information about the nature and location of the arc fault. As arc fault protection technology continues to advance, it's likely that F-sides will become even more prevalent in residential and commercial electrical systems. In summary, while smoke detectors themselves do not need to be on arc fault circuits, almost all 15 amp and 20 amp circuits supplying receptacles and lighting do require arc fault protection. Remember to consult with the latest NEC and local amendments for any specific requirements in the location. Always prioritize safety and ensure all installations are done by qualified professionals.